Alright, so why change to vertex form? Why is this form so great? Well, you know how you guys always ask me, like, how the heck do you do graphs like that, and how do I visualize a lot of things? More about that. Vertex form usually helps us see visually what our transformations are going to do to parent functions. What the heck is a parent function? Parent function is the most simplistic a graph can be. So when we're looking at a parent function, we ignore all multiplication, all division, all subtraction, and all addition, except exponents on your axis. Alright, so looking at this, I need to draw a graph of y equals x squared. So when in doubt, t-chart it out. Got an x, I've got a y. I'm going to start, for example, at -2. -2 squared should give me +4. -1 would be next. -1 squared should be +1. 0 squared should be 0. 1 squared should be 1. And 2 squared should be +4. So now I'm going to go ahead and graph that. So I've got 0, 0. 1, 1. 2, 4. -1, 1. -2, +4. I'm going to try that a little bit again, because apparently I'm going to miss my points. Alright. And then my next little bit would be at -3, +9, and +3, +9, because 3 squared would be 9. Alright. So that is my parent function of every single parabola. So anytime I see something having to do with an x squared, even if it's like x minus 3 quantity squared, eventually my largest exponent I'm going to have on my x is going to be a squared. So my parent function is still going to be this mess. So what does this vertex form of parabola look like again? Well, the definition and transformations are listed. So my parent function is always going to be y equals x squared. If I have, for example, vertex form, which is y is equal to a times the quantity of x minus h quantity squared plus k, my axis of symmetry is always going to be x is equal to h. Like I said earlier, my x coordinate of my vertex should always match my axis of symmetry. Going on, my vertex should always be h comma k. My domain of any parabola is always going to be all real numbers, meaning there is never going to be an x value that I cannot plug in. And just to make our lives easier, k is always going to be where my range is at, because again, my vertex is either where it bottoms out, or it's going to be where it peaks like a mountain if it's a -a. So if a is negative, all we do is flip the inequality sign for the range. That's it. So what would I do? Well, if I have the parent function of y equals x squared, I am going to shift my entire function h units right if it is a negative on the inside with that x. If it is a x plus h, then I'm going to shift h units to the left. If I have an a larger than 1, I'm going to actually multiply my y's by a. And then if I have plus k on the end, I am going to shift k units up. If it's a minus k, I'm going to shift my entire parent function down k units. And again, domain and range, see in the other column, it's right here. Cool. So we will need to use one column or the other. If we're using the definition column, just plot the vertex and the axis of symmetry, then we'll make a small t-chart for one side of the axis of symmetry. And if we're using transformation side, we're going to start with the points that we found on problem 0.2 and perform all of those transformations on them in order that I gave to you. So the transformations column. All right. Graph each of the following functions. We'll get to those here in a second. Look out for next video.